the most important thing in the welding, you have to be sure that the welding center of the pin is the same as the center of the weld. How can we ensure that we put or set or fix the workpiece or the test specimens in the same line of the center line of the pin or the tool? Actually, we arranged to fabricate 2 jigs, flexible jigs. It can be moved by this bolt, and we adjust it with a distance. In order, distance will help us to put the workpiece in the same center line of the pin. We can do it now. Also, we use actually stopper here. This is stopper because the axial force is very high, and the fixtures will not be able to fix to get a precise or adequate fixing force without put some stopper. So the stopper will prevent the workpiece to move along the welding direction. You can see, you can put these jigs, 2 jigs here. Should be perpendicular with this face. This is the back face, and we have to put these 2 pieces together perpendicular to this. So we have to move this to be in touch for both jigs, and to move the workpiece to be in touch with the stopper. This is the correct position that will be sure that this line is the same line of the center of the pin. Now we can go ahead with clamping.
Help there.
Just let me see this.
Do you want to
I need to move it.
Yeah.
Yes.
Now?
Yes.
Oops. It's okay. I thought the one from there had moved actually, but this one.
So you can see the stopper thickness is less than the workpiece thickness. The stopper. This is the advantage of this. So we need to make a fixation on the workpiece and not fixing the stopper.
Good?
Yes. So you can use this.
Yeah, it has a bunch of burrs.
Oh, sorry.
Oh, sorry.
touch the fixture there or jigs, and also it is touch the jigs and it is touch the stopper. Now we are sure that this work test specimen is in the center line. We bring the other one.
That the piece that was there? Seems short, but I don't know, whatever.
I guess this.
Ah, there you go.
because it is too short. This is the problem. It's not a standard.
Is that the same size as this one?
Yes. No, this is.
Maybe this one is slightly bigger.
Let's see.
Maybe one, although this one is kind of bigger too, so I don't know.
Yes, let's see.
Same?
No, this is.
Actually worse.
Yeah.
Slightly.
Let's see.
Same.
Now the fixation is okay. Second thing, we need to measure the distance of the weld, the travel distance.
You know, the pieces are a little bit open here. Is that okay?
Yes, yes, because this weld is not, this with this is not in a parallel.
Yeah. It's okay.
Just to see what's the depth of the weld. So we have this caliper to see what's the distance that we need to go. Let's start from, let's say, from 20 millimeter or 1 inch, less than 1 inch. Let's put it in inch because the machine is working in inch. So let's say we start from 0.6 inch. So the start point is here, and we can see what's the travel we need. So it's 5.2 inch. 5.2 inch. Starting from this point, so the travel will be 5.2 inch. The best thing for this, you have to do a test run on a safety margin. This is the first time that we found this trick in order to use the friction stir welding in the air, or as say a dry test. The dry test, we have to make a trick on the machine. We have to get impression. That's the 0 point is not touch on the real surface that we need. So we have to put a spacer, and then we make a 0 on the spacer, then we release the spacer, so the machine will get impression that the 0 point is on this point, not on the real point. So we will be sure that all the tests will be done on the air without any interruption or any unexpectation what will happen during the welding, because we are not sure that the movements, that the orders, the commands are correct. So we have to be sure everything is correct by using a dry test. Yeah, this is okay. So here we have to make a 0. To make a 0 for set point, you have to push 0. So the readings set to 0, and we have readings here, and we have to set it to 0 position. So we got a 0 as well. So we got a 0 for x-axis and z-axis. Then, after finish of this step, we have to go to another step. This is a schedule sheet. What's the program name, job name, weld name? Let's say weld name is Hazen. April 11, 2004. So it will be okay. We have to select one of these and we make amendments on these templates. So I prepared this program previously with these movements. We can make edits. So we got this screen. The travel axis now is 6.3.
What is the inches?
Yes, we measured it as...
Is that the length of the weld?
Yes, we measured it as 5.2. The linear velocity is 3.66 and Z position is 0.272 and Z or Z velocity is 0.15. Good time is...
What is the C position? The C position is how much it's going to die.
Yes, yes.
And the Z velocity is how fast it's going to do it. Is that inches per second or what is that?
This is inch per minute.
Yeah.
And this is in second. As soon as we finish this step, the shoulder will only rotate without movement for 5 seconds before going ahead to the second step.
Yeah.
This is the plunge step. Or start-up segments. Start-up segments. This is the maximum expected Z force.
So it is measuring the force as well?
Yes. And we have 0.272 and 0.15. The revolution per minute is 309. This is for the first start segment, and this is for a linear movement. And this is for the last or termination segment. Termination segment means what's the safety margin that we have to go after finish the
So
work.
this one is the plunge.
Yes.
This one is the linear movement.
Yes.
And then this is what it's going to do, which is probably
Yes.
lift up, right?
Yes. So the direction or the signs here is for plus sign means the movement will be downward after the 0 point.
So this negative means it's going.
Yes.
Got it.
Yes. This is the direction. Now we put this with a some clearance. We set it as a 0. Now we finish the update and we amend the movement to 5.2 and the plunge depth to 0.272. Then we have to push update. Now it is ready to go ahead with a weld.
If when you are doing the weld, you find any problem, you can hit the red button, right? The stop.
For here we can't do, but in case it will go, yeah, we can't go, we can.
If there is a mistake, like you realize.
Yes. So we finish the schedule, select, and then we go ahead to weld. For the weld, actually the first thing that we have to make a 0 point, we have to be sure. We have two functions or two alternatives to go ahead with the 0 point. One based on the laser sensor, which is not available now. It is available, but we didn't use it before. And we can go ahead with the Z position. Z position, this move, we have to move the tool very close to the workpiece. So now we suppose this distance as a workpiece. And then we have to put this, activate a Z position instead of laser. This is very important to go ahead with the 0 point. Now press on 0. So you get a screen or alarm. This will move Z axis inward until force is detected. So this detection will be based on the touch, actual touch between the tool pin with the workpiece. So we put this strip in order to give impression that the workpiece top surface is in the top of the strip to be sure that it will be work on the air. Should be very close here, so we can release it very easy. When we push yes, you can see what the function will be done here. It will move up first, and then move down until get the force. Now it will detect the force. The force is very slow now, very low. So as soon as the pin will touch this strip, the force will be increased. Now we have a very slow movement of the tool.
Still have it done.
Yes, still have a gap because it moved. You can see. Yes, now it's okay.
Yeah, now it's going up.
So it detects some force. This gives impression to the machine that the pin now is in contact with some force with the workpiece. So it is okay. Now the machine is ready to start the program, but we have a strip here. We have to release the strip. So from this 0 point, the machine will go ahead with the Z-axis that we programmed. From this, the machine now consider this is the 0 point. We have to start the program. We just push on this, and we can see what will. So the machine start. And this is first, the target depth is 0.272. This is the target depth. So the machine will go ahead in a plunge until the actual position match the target position or target depth. Then the machine will make some drill for 5 seconds as we used. Then we'll go ahead to the next step, which is belong to the linear movement. You can see this is the instructions of the plunge force. So in case of any accident, we can just push stop, the machine will be stopped. So in case of some emergency, you can go ahead to push this emergency to be sure that everything will be stopped. We have here Z force detection and X force detection, as well as torque. You can get readings of the torque on the bed and on the head. Now it moves. You can see the movement in the x-axis. It's finished. The depth limit 0.27 and the target was 0.27, the same. Then the next step is to go ahead with the linear movement, which is named as travel movement. Now it's finished. Is move upward to minus 0.5 inch. It's a safety margin. So the position is 0.296. This is 0.5. Now 0.4, 0.49. Now it is 0.5. So everything is done. Now we got this message: the system log file has been exported into an Excel separated sheet and saved as U of M test 1 as in April 11, 2014. This is the name of the file, which includes all instructions, included movements, forces, and torques. You can go ahead to see this file. So now we have to push return. It is okay. You can move the machine again up. And return to the start point. change the feed of the Z to 1 because it is very close.
That's to go slow, right?
Yes. You can see it very close to see it is in case it is very close, we have to put some safety margin between
You might
the.
want to see it this way so you can see
Yes.
how much the space is. But
Yes.
lower the camera. Let's see. You can put it down there. Now you get it instead of using the zoom. Can you get the zoom on? Because the camera is not very good at getting.
Yeah,
that,
now
you
it
know.
is good. Okay, this distance is okay, but we have to move the tool in x-axis. Also allows speed.
Yeah, auto adjust to when you zoom in after a while.
The other way actually. Ah, there you go. Sometimes if it is too far off, it takes out exactly. There you go. So if you could do it by little, you can get better.
No, this it should be not touch with the workpiece.
Right, it should be a little bit up.
Yes. Now it is up. We can go move down, or we cannot. I believe we have some way to go. Now is yes. Now it's okay. You can take a look on the safety margin between the